presentation will be on the impact and challenges of long-term thermal storage. And I would like to organize the presentation like that, that I would like to go into the research questions regarding seasonal thermal energy storage that our team is looking at. Of course, we are a technology team, so that's where the main focus is. And nevertheless, we see that it's absolutely essential to look at the full scope. And this is here organized in this talk in political, economical, social, technology, environment, and legal research questions that I would like to cover here. Before doing so, maybe one word on seasonal thermal energy storage, so on what it's about. As an introduction here, a technology radar, which kind of technologies we have available for storing thermal energy storage, so for storing thermal energy over a longer time period. And here you see on the one hand the so-called sensible technology, so meaning we heat up and cool down a material, which is typically water or the soil or kind of rock substance, for example. And then we have latent technologies, which are at a lower technology readiness level. So meaning with latent, we change the phase from solid to liquid or from liquid to gases. And then thermochemical energy storage, as the word says. So there we have a chemical reaction or an adsorption-absorption process to store the energy. The radar shows here, so which ones are in operation and where we are on a lab level or prototype level. So just to get a bit an insight here, so the big possibilities are, for example, so-called pit storages or our borehole thermal energy storage, as for example in ETH we have, or as well at HSLU computational science at these places where we have borehole thermal energy storages, and then so-called aquifer thermal energy storages, so going into the ground and using big water reservoirs or using stones. And there, for example, in Bern, currently, there are big drillings which are going into these kind of directions. And as well in Geneva, for example, one looks at. So with this short introduction about what are we talking about here, now I would like to start having a look at the political aspect, basically the research questions: where, when, and which large-scale facilities should be installed in Switzerland to ideally exploit its potential, and then, of course, looking as well into the future where we could talk about policies further. So in this context, maybe what we have achieved so far, together with, as well out of this scope here, together with Gianfranco Guidati from the Energy Science Center, we have published towards the politics a position paper around the possibilities of seasonal thermal energy storage and driving that already for quite a while. And well, the outcomes at the end that we gave to politics were that one really has to have a look at spatial and energy planning, that it needs first projects that can be copy-pasted, and that on a research side there should be more knowledge and understandable, especially in the let's say in the context as we do it in Pathfinder, where we look at the big energy models altogether. So having a broader look, so at the moment we use 46% of the annual end energy for heating and cooling. This is typically, when asking lay people, the answer is typically by far lower. So one sees the big lever arm that is in the heating and in the future more and more cooling sector. When looking into then the energy system models, looking into 2050 or into the completely decarbonized system, Then as well here together with the ETH Energy Science Center, one can see some results. So typically these complete system models show for the decarbonized energy system in Switzerland an order of magnitude of 10 terawatt hours in winter that are non-covered, or where one has the discussion, how could we cover these in the future by imports, by increasing the dams, etc. When we look into seasonal thermal energy storage, so this component out of the many important components in the energy system, so zooming into this one and looking into the effects that this one can realistically have, then we see a potential of up to 4 terawatt hours electric that can be reduced with these technologies. So this means we are not talking about a small thing, we are really talking about a big lever arm within this discussion of the so far under debate winter electricity, additional winter electricity demand. Where do we want to go after this position paper that we had already published? Well, as well, together again with the ETH Energy Science Center, we are working on this position paper 2.0, let's say it like that. So we want to go more into depth where, when, and which large-scale seasonal thermal energy storage facilities should be installed in Switzerland to ideally exploit this potential. And here, of course, Pathfinder is as well one big project in there, other suite projects where we are involved, and then one big flagship InnoSwiss project where we look as well into this potential, looking, for example, with GIS-based assessments, where could these be? And out of that, then have a paper towards politics again in about 1 or 2 years, where we can say more explicit where should it be, and then have as well recommendations around policies. Then as a next step, looking into the economic aspects. So from our perspective, our research question here is how to reduce cost of seasonal thermal energy storage technologies. And well, here, let's say it like that, whenever we look at the whole energy system and when we look at the different technologies, one can say size matters. So the bigger, the better. So on the one hand, of course, then the technologies get bigger, which means that the surface area to volume ratios get better in terms of losses. So this means we have lower losses with bigger systems. And then, of course, the specific costs go down for the bigger system. So we should think mainly within thermal grids and within bigger building contexts. And then, of course, there can be activities on the smaller buildings, but there is, let's say, less focus. So what possibilities do we have there? That depends, of course, on the different technologies. I've shown before photos from them. So when looking at these pit storages, for example, one can look into using these surfaces, not just once, but more than that. And so not just for this pit storage alone, but how to use it for other possibilities. So like, for example, having buildings on top of that, or possibilities on top of that. So that could be one of the means, and it's just one example out of the possibilities. So when we go into these costs, these specific costs, then to quantify that, we see here, for example, here on the x-axis, we see storage capacity, and then we see energy. On the y-axis, energy-specific investment costs, euro per megawatt hour, and the dots are different already built systems in the European context. In pit storages here, for example, in borehole thermal energy storages, in aquifer thermal energy storages, or with tanks. And one sees this clear dependence here on the size, and that, well, here quantified how clear it is that we should think in a bigger context. So our research is, of course, one part of our research is around bringing these costs down. And to show one example here is our possibilities to use cavities, so already available cavities. So this can be in the building context, but this can be as well tunnels, this can be bunkers, this can be underground cavities which are available, which we have quite a lot in Switzerland. And for that, we have driven a series of so-called GEAS projects on developing diffusion, water vapor diffusion tight and insulation barriers here for these kind of cavities. So this looks then like this. And here one can see one pilot that we have already installed working on that up to, at the moment, 60 degrees C. Where do we want to go with that in the future? Well, in the future, we would like to drive that to bigger possibilities and as well to higher temperatures. And for that, we have different projects running, like shown here. And at the end, what we see critically in here is, again, material science, so working on these layers, which play a role in pit storages, but which play as well, especially a role in these reused cavities. And so there the core is around these water vapor diffusion tight insulation systems, where other groups as well in Europe and in the world are working on, and where we look for solutions together. Then going into the next step, into social aspects. So our research question here, how to increase the social acceptance of seasonal thermal energy storage technologies. And with that context, we have one bigger fundamental research project running together with colleagues from University of Bern from political science. And this project is called SOTES. And here we have first preliminary results. One sees, first of all, that the society basically doesn't know about it. So acceptance is basically awareness. So there is, in this case, not that much awareness about it. So many people are not at all familiar. Different to other parts of the future energy system, like batteries, like maybe hydrogen and other technologies. Looking at what can help to increase that, well, one has first findings, and one sees that out of these findings, one can say that a perceived usefulness helps to install on the one hand, and that video-like information increases that significantly, basically. So if we want to drive this awareness level, then we should work with videos, with movies, etc., towards politics and lay people. And then one recent finding, which is from my perspective very important already, is that public ownership, so or perceived public ownership of such an installation increases significantly this acceptance. So this means when we plan for these big infrastructures, it's important that the awareness of these is a public awareness and not company awareness of someone who buys that. That shows as well what role our energy providers should play. They should be a public, they should seem to be public, or they should be perceived as public companies. So where do we want to go from here based on these preliminary results? Well, there is, of course, this project SOTES running further, where we want to go further into then modeling, combining techno-economic and social-political assessment. And out of that, one main goal is as well that we would like to create kind of decision tree selection processes to ease selection processes in the future. And another aspect is around awareness, so around the dissemination. So there we have projects together, or started project together with movie making at our university in the design and movie department, where we try to bring out movies around this topic. Then would like to go into technology aspects. Well, here, of course, the main research question, sorry, I'm going back, is how to increase the compactness of thermal energy storage. So that's this combined with the costs, of course, is the main driver. While here one sees for sensible thermal energy storages, so for water-bound systems, that the stratification is very important. So this means that the cold stays at the bottom and the hot stays on the top. This is, for example, important when we think of tunnels in the future where we don't have these perfect geometries, or when we go further. So here, based on our models and based on then control algorithms and looking into model predictive controls, here one can see that when knowing how this works and going into the right control algorithms around that, then in examples we have proven that we could reduce the storage volume by 40% working on that, just by controlling and understanding the storage perfectly. And then, of course, it's about other materials. So here we come into latent materials. Here our team is rather active over a long time in material development, and here mainly focusing in inorganic PCMs, because one can see that they have melting temperatures which are kind of in the right range for the residential and low process heat temperatures, and we see rather high volumetric heat capacities here on that side. And well, when we go into that and combine that, then one can see that on the basis of one bigger project context, where we try seasonal thermal energy storage with combining sensible, so water and these latent combinations. And here we have an overall system model, including greenhouse gas emission, including technical economical costs. And then we calculate Pareto fronts based on an overall optimizer going into the complete system, here on the example of a multi-family house. And when doing so, and when using different storage concepts with bringing in the latent material with different shapes and different possibilities, then we see results where we have greenhouse gas emissions overall, which are fine, and where we can get into really rather small concepts for multifamily houses. And for example, going into these kind of Pareto fronts and seeing then the results, then one is in the range of, for example, 10 cubic meter plus to reach like 85% heat autarky for multifamily houses. So this means I have a 10 cubic meter tank in that range, and so here like 8 cubic meter, 85% heating autarky of this multifamily 8-apartment building. So we are getting there into rather attractive ranges. And then the third technology that I would like to mention, which we are looking at in our labs, is based on thermochemical storage. Here, a concept shown on sodium lye, here with an absorption technology. And one sees here a concentrated and a diluted sodium lye, which are here tanks in the size range as they would be necessary for example, single family house. So here we are in an oil tank range size for then allowing with absorption heat to heat our houses of the future. And this is, of course, on a rather low technology level. Nevertheless, we will install now in the next winter season, then we will install something outside of the lab already as a first prototype. So what's next to come? Of course, this is where most of our projects are. We want to go further with better latent materials, but as well, we would like to increase on sensible energy storages, its possibilities, and these thermochemical parts are going further. So now going into environmental, how can sustainable use of resources be guaranteed when developing and using STs? So here, honestly speaking, we do not have that much yet. We have now bigger activities in going deeper into LCA, so levelized, so into life cycle assessments for all the different seasonal thermal energy storages. But just to show one example here where we have published is on sensible energy storages, where we show that let's say one has reasonable greenhouse gas emissions in comparison to other systems. So the future here is really around understanding more where are the big lever arms for greenhouse gas emissions and where do things have to be changed in the future to completely decarbonize as well this production. Then at the end, going into legal, here we have one main project running together with Professor Abeck from ZHW, who is driving this project on legal measures. So which legal measure accelerates the spread of seasonal thermal energy storage. And here, well, one sees first points. One sees, for example, that increasing temperatures in the ground, how much is that possible, is one of the barriers, one of the challenges. And then being able to build these things in a faster and better context are the things we will look at. So I'm coming towards the end of my presentation, showing again here these different aspects and the challenges around seasonal thermal energy storage, which we like to address and which we think that are important at the end to overcome in terms of challenges to drive this technology towards our future energy system. Some more links and literature you can find then in the presentation as we hand them out, for example, on this position paper, for example, on the big project which is running in parallel to the SWEET project, the Swiss STs, and then on our LinkedIn page. For those being more interested, we will have a PhD summer school already, the 4th in a row, on thermal energy storage this summer, which we do together with the University of Padua. And we have, as every year, our Swiss Symposium Thermal Energy Storage on the 24th of January 2025. And of course, it would be wonderful if we had as many from Pathfinder in there as well as possible. So with that, thanks to the team from our competence center, and thanks, of course, for everyone listening and for the wonderful community within Pathfinder. We just had the site visit here at our place, and it was a pleasure to have everyone together here from all work packages. Thank you very much.